Okay, so let's first talk about the mean x bar, standard deviation s, and confidence interval question. Okay, confidence interval question. So the first example. So suppose we measured 5 flowers. Okay, so size of n equals 5 flowers. Okay, so that's the size of flowers, diameter in inches, right? So the first flower 2 inches, 3 inches. The second one is 3 inches again, 8 inches, and then 14 inches. Okay, so there's a garden. We pick 5 flowers and then we measure them, right? 3 small and then 2 big. Okay, 2 big. So first, in the midterm, before the midterm, we already studied how to find the average, the mean, x bar, and standard deviation. As using a table, right? Using a table. So the easier one is mean. So the formula is sum over n, right? Sum over n. So you just add all the given numbers. And you're adding 5 numbers on top, so n is 5 divided by 5. Okay, so the sum on top is 30 divided by 5, so we got x bar is 6. Okay, x bar is 6. So now the formula is for s is the square root of sum of squares divided by m minus 1. Okay, divided by m minus 1. Or sometimes we find s squared first. So this is sum of squares divided by m minus 1. So here, what's in this parentheses is x minus x bar. Okay, so most cases we use a table to find this, right? We use a table to find this. So we have x minus x bar, and then x minus x bar squared. Okay, squared. And then there are 5 given numbers, so we have 5 rows. And then the last row we call it sum. So before we add, we know the sum of the middle column should be 0, right? Middle column should be 0. And then the last one we got, the last sum we got is the sum of squares. Okay, so that's the numerator for s squared, right? The numerator for s squared. Another example is here. We get x1 is 2, the first given number, and then we have 3, 3, 8, and 14. So now we know x bar is 6, right? So here will be everybody minus 6. So 2 minus 6, this is -4. 3 minus 6, this is -3. And then -3 again, 8 minus 6, 2. And then 14 minus 6, we got 8, right? We got 8. So now square part, because we are using calculator and sometimes you don't know how to click second power on your calculator, right? That's why we use the number times itself for squares, right? For squares. So this is -4 times -4. We got positive 16. Okay, so every number you got in column 3 is a positive number, right? It's a positive number. So this is -3 times -3. This is 9, so it's the same thing. 2 times 2 is 4, and then 8 times 8 is 64. Okay, 64. So now you add everybody in the last column. Okay, in the last column, you got 102. Okay, so it's 16 plus 9 plus 9 plus 4 plus 64. Okay, plus 64. So you have to show me this table to find the sum of squares, right? Sum of squares. So now n is 5, so n minus 1 is 4, right? So this will be s squared is 102 divided by 4, which is 25.5. So s is square root of 25.5, which is 5.05. Okay, 5.05. So this is what we did for the x bar and s. Okay, x bar and s. So now let's talk about the confidence interval in lecture 11. Lecture 11. So let's copy the information in the previous page. We have n equals 5, and then we have the 5 given numbers for the size of the flowers. And then we got their average is 6, and then as the standard deviation is 5.05. Okay, 5.05. So now in lecture 11, we studied something called confidence interval. Okay, confidence interval. And then there will be a given percent. Okay, it's a big percent. It's 90% confidence, or 95, or 99, or maybe even 99.9%. Okay, 90.9%. So now let's choose 90% confidence interval, right? So part B, we want to find 90% confidence interval for the mu. Okay, so what's mu? Mu is the average of all the flowers in this garden, the average size in diameters, right? In inch, right? In inches. And then x bar is only the average of these 5 given numbers, right? 5 given flowers. So their average is x bar, so we want to know what's the range for this mu. Okay, what's the range for this mu? Okay, yeah, so the answer you get, it will be mu is greater than x bar minus e, less than x bar plus e. So here x bar is 6, and then e is something called the arrow. Okay, the arrow. So now to find e, we need a given formula. So e is Tc times s over radical n. Okay, s over radical n. So now here we know s, right? S is 5.05. We know n. N is 5. So this is radical 5, right? Radical 5. So now the key job is use table 4 to find Tc, right? To find Tc. Okay, so now I will talk about how to use table 4 to find Tc, and then we will go back to this question. Okay, we will go back to this question. Okay, so this is table 4. So here you see this is the first column. So there are some integers. So the first column is n minus 1. Okay, n minus 1. Okay, so this is the df, so the degree of freedom. So df is equal to n minus 1. Okay, n is the size of samples, right? N is the size of samples. So how many given numbers? Okay, how many stores you visited? How many students you get? Okay, so how many number you measured? Okay, you measured. That's the size of samples. So now the first column is n minus 1. Okay, n minus 1. So for our example, the flower example, n is 5. So we need row n minus 1, so which is row 4. Okay, which is row 4. So now let's circle the row 4. So this is row 4, right? Okay, so we are looking at this row. So now which column, which number we need in this row depend on the given percentage. Okay, so that's called confidence level. Okay, confidence level. So they said find 90% confidence interval. So where is this 90% in the table? 4 is the bottom of the green part. Okay, so this line is the given percentage. Okay, given percentage. So 90% is 0.900. Okay, yeah. So if this is 95% confidence interval, then you should use 0.95. So if this is 99%, you should use 0.99. Okay, 99. So forget about the third digit. We mainly look at the first and second digit after decimal point. So this is the percentage. Okay, this is the percentage. So only the last number you should be careful a little bit. So 0.99.9. 0.99, 3 nines there, right? So this should be 99.9%. Okay, 0.9%. So before the last one, except the last one, everything you need is the 2-digit after the decimal points. Okay, after decimal point. So now for the flower example, we need 90%. So this is the column, right, for 90%. Okay, so now they meet the row 4 and 90% column. We got this TC. TC is 2.132. Okay, so this middle number, this number, right? This number is in the middle, right? It's in the middle in row 4 and 90% column. Okay, so that's how we find TC. Okay, that's how we find TC. So now let's find another one, right? Suppose they said, okay, N is 22, and then let's find 98% confidence interval. Okay, and then what's the TC for this one? So first N minus 1, so row is 21, so N minus 1, and then 98% column. So now first 21, so this is 21, right? And then 98 column, so this is the 98 column, right? 98 column. So it's 2.518, right? 2.518. Okay, that's how we find TC using table 4. Okay, using table 4. Okay, so again, so the first column here is, this is N minus 1, and then the green part, the bottom of the green part is the percentage confidence level. Okay, confidence level. So now let's go back to our calculation for the confidence interval. So we know TC is 2.132. So this is 2.132 times 5.05 divided by radical 5. Okay, so use calculator, you can get 4.81. Okay, 4.81. So that's the arrow part, right? So that's how far away x bar and mu is. Okay, mu is. So now the answer is mu is greater than x bar minus e. So x bar minus e. So this is 6 minus 4.81. So this is 1.19. So that's the lower bound for mu. And then this is mu plus e. So this is 6 plus 4.81. So this is 10.81. Okay, 10.81. So this is the answer for part B. So from 1.19 to 10.81 is the confidence interval. So you can also use the interval notation for the answer, right? So that means 1.19 to 10.81. So if you don't know interval notation, you can use the inequality. Okay, you can use the inequality. Okay, yeah. So the first part, to find x bar or to find s using the table, is not new. Okay, it's not new. And it should be easy, right? It should be easy. Only the second part. But second part, all these numbers, all these formulas will be given. Formula 1, formula 2, they are given. Table 4 also given. So the key thing is, you find this percentage, you know it's a confidence interval notation, then you just follow these formulas. Given formulas 1 and 2, use table 4 to find TC, then you got the answer. Okay, then you got the answer. So that's the question about confidence interval. Okay, confidence interval. Okay, so now let's look at the question about binomial distribution. Okay, binomial distribution. Okay, so before that, first we have to know what factorial means, what the combination number C and R is. Okay, C and R is. So the formula for factorial, the definition for factorial is not given. Okay, it's not given. So this is the product from all the numbers between 1 and n, right? Between 1 and n. So this is multiplied n minus 1 until you got n, right? So if this is 3 factorial, that means 1 times 2 times 3, so 6. This is 5 factorial, then this is 1 times 2 times 3 times 4 times 5. So this is 120. Okay, so factorial is the product of all the integers between 1 and n. Okay, between 1 and n. So this is the one you have to remember. So the next formula will be given. So I change it to red. CNR is n factorial over r factorial times n minus r factorial in the denominator. Okay, denominator. So let's still use 5 and 3, right? 5, 3. So C 5, 3. So this will be n is 5, r is 3. So this is 5 factorial on top. R is 3, so this is 3 factorial. And the n minus r is 5 minus 3 factorial. So top is 1 times 2 times 3 times 4 times 5. Bottom, this 3 factorial. We use red color. 1, 2, and 3. And this 5 minus 3 is 2 factorial, right? 2 factorial, we use this blue color. Okay, blue color. And then we multiply these two factorials together, right? So top is 120, bottom is 12, then this is 10. So C53 is 10. Okay, it's 10. So we need C and R to solve the binomial question. Okay, to solve the binomial question. Okay, so we will talk about 2 examples in lecture 8. Okay, in lecture 8. Okay, so first let's look at this question 8.6. Okay, 8.6. Okay, yeah. So let's look at the given formulas, right? Given formulas. So first, there is a C and R in this formula. That's why we explained C and R first. So let me repeat the formula for C and R is n factorial over r factorial times n minus r factorial. So that formula is also given. Okay, that formula is also given. Okay, yeah. And then r is the number of success. Okay, r is the number of success. Okay, so that's the way you identify this question. Okay, so let's look at 8.6. So they said there's a drug, 85% cure rate, and then the total number of patients is 15. So this is n. Okay, this is n. So now, what means number of success? So they said at least 13 are cured. Right? Yeah. So these patients, they tried this drug and then cured. That means success. Right? That means success. Okay. So question A, they want to find the probability that R is greater than or equal to 13. Okay, equals to 13. Then you know it's a binomial question. Okay, 15 people tried, 13 cured. Okay, 13 cured. So another hint is they want you to find the expected value. So this is also the mean, mu, and the standard deviation, sigma. Okay, sigma. So in part B, they ask mu and sigma. That's also a way to find this question. Okay, to find this kind of binomial distribution question in the exam. So now part B is easier because the formula of mu and sigma is easy, right? Mu and sigma is easy. So now what is P and then what is Q, right? P is the probability of success and then Q is 1 minus that. So that means Q is the probability of fail, right? Of fail. You didn't success, right? Didn't success. So let's write down those informations for the 8.6. For first, P is 85%. So Q is 1 minus P. So it's 1 minus 85%, which is 15%, right? Which is 15%. Okay, yeah. So that's P and Q. Okay, P and Q. Their total is 100%, which is 1. Okay, which is 1. So now mu is n times P. So n is the total number of patients. How many people tried? Okay, how many people tried? We don't care is cured or not. Okay, cured or not. So they tried drugs, that's n. How many cured? That's r, right? That's r. So n times p, so this is 15 times 85%. So we should use decimal. 15 times 0.85 or 0.85. Okay, 0.85. This is 12.75. That's the mu. Okay, that's the mu. So that means in average, 12.75 patients will be cured. Okay, will be cured. Okay, that's the average if you try 1 million people, right? If you try 1 million people, so 15 million people, let's say 15 million people, then 12 million, 12.5, 75 million people will be cured. Okay, it's a big proportion, right? It's a big proportion. Okay, yeah. So if you try 15,000, then this is 12.75 thousand people will be cured. Okay, yeah. So that's the meaning of mu. Okay, that's the meaning of mu. Okay, yeah. So now what's the standard deviation? Standard deviation, the formula is sigma MPQ, right? MPQ. So this is sigma. So N is 15, P is 85%, Q is the opposite, so 15%, right? 15%. So use decimals, 0.85, 0.15, then you got this is 1.9125. The product, square root of that is 1.38. Okay, 1.38. Okay, so part B is very easy, right? Part B is very easy. Okay, yeah. So now let's look at part A, right? Let's look at part A. So part A, because the C and R calculation is complicated. Okay, there are a lot of factorials, or maybe there's a big product. Okay, big product. So that's why for part A, I will just need you to write down the probability question, and then list out the PRs. Okay, list all the PRs. So now let me try to do that. Okay, so what means list out the PRs? So the question A is we want to find the probability that of R is greater than or equal to 13, right? So R means number of successful, right? Success, so that means how many patients cured. So bigger than 13, so first you have 13 patients cured. And then you can have more than 13, so it's 14. And then you can have all the patients, the total is 15, so at most the maximum is 15. Okay, 15. So you list all the possible cases for R. Okay, possible cases for R. And then for each R, you write down the binomial formula, binomial probability, right? Use this formula for PR. So let's use a red circle for PR. Okay, for each R, you use this formula, right? You use this formula. So I will try to use 3 different colors, right? So first we use blue for this R equals to 13. So C R and R, so it's 15, 13. So that's C and R, right? R is 13, N is 15. And then we got the P's power. So this is 0.85 to the R's power, 13. 0.15 to the 2's power. Okay, so this is equal to 0.85. This is equal to 0.15. Okay, 15. Okay, so 13 patient cured and 2 didn't, right? Or maybe pending, right? Maybe pending. So that's R equals to 13. So now let's change to orange. So R equals 14, right? 15, 14. So that means this is power 14, and then the other one is the patient pending or doesn't work, right? Doesn't work. This is 0.85, this is 0.15. Okay, so the sum of power is always 15 because there are total 15 people, right? 15 people. And the last one we use red. So this is plus C 15, 15. N is 15, R is 15. Okay, R is 15. So this will be 0.85, 15, and then 0.15, 0, right? 0. Okay, so you have 3 cases for R's. You have 3 binomial probabilities. Okay, probabilities. Okay, yeah. And then just leave like this. Okay, leave like this. Okay, to save time. Okay, we already tested the notation C and R for smaller numbers before this kind of question. Okay, before this kind of question. So this is 8.6. So now let's look at 8.9. Okay, let's look at 8.9. Okay, yeah. So now let's first write down N, right? How many people selected in this example, 11 workers, right? 11 workers. So N is 11, right? And then P is the probability of success. So 15 of them call in sick on their birthdays. Okay, yeah. So P is 15%, and then Q is 1 minus 15%, which is 85%. Okay, and then we also change them to decimal. So this is 0.15, this is 0.85. Okay, 85. Just the first two decimal places, right? First two decimal places. Okay, so now we are ready for the question 8, right? We are ready for the question 8. They said at most 2 workers call in. So that means R is at most 2, right? The A part is always for R, okay, for R. So we want to find the probability R is less than or equal to at most 2, right? At most 2. Then we have to list out the possibilities, right? So what it means less than 2 employee call in sick. So nobody call in, that's 0. And then 1 employee call in, and then the other case is 2, right? Is 2. Okay, so that means at most 2 workers. Okay, 2 workers. So now we need the C and R formula for each R, right? For each R. So this will be C 11 0 because the total N is 11, right? N is 11. So 11 0. So this is N, this is R. Okay, yeah. And then nobody call in, so 0.15, 0 power, 0.85, 11 power. Okay, so this is R equal to 0. Okay, R equal to 0. And then R equal to 1, we change the color to orange. So this is 11 1. So that means 1 employee called, the other 10 didn't call, right? And then change to red. So R is equal to 2. So C 11 2. So 2 of them called, and then the other 9 didn't call. Okay, didn't call. So this is the probability for R less than or equal to 2. Okay, don't forget this case R equal to 0, right? R equal to 0. Okay, so R is always between 0 and N. Okay, so that's a note. So let's put it here. N is the size of the sample, right? N is the size of the sample. So 0 is less than or equal to R less than or equal to N. Okay, so that's part A. So part B is much easier. Mu is NP. So mu is 11 times 0.15, so which is 1.65. And sigma is, mu is expected value or mean. Sigma is the standard deviation, right? So sigma is radical. 11 times 0.15 times 0.85, right? So this is M, P, Q, and square root, right? And square root. So this is square root of 140, which is 1.18. Okay, which is 1.18. Okay, so this is the binomial distribution question. Okay, question. So my suggestion is first you remember to try to understand the expected value and mu sigma formula, right? For sigma is standard deviation. That's much easier. And then you understand this R, right? And then you understand this R. R means how many people called or how many people patient cured. So in other questions, so how many students live at home, and then how many adults pretend not to be at home. So for 8.10, that's the insurance, right? Workers who get insurance, that's the number of R. Okay, that's the number of R. So R is a part of N, right? You're given some examples of size N. A part of success, that's R. Okay, yeah, the other part is just the opposite, right? Opposite. Okay, so that's it.